You have a mathematical model and you have some data. You want to estimate now your parameters in the model, but you don't quite know how to. You don't really have a lot of programming experience, and you just want to find a nice graphical user interface. Then this tutorial is for you. Hi, and welcome to a short tutorial on the PEtab-GUI, a graphical user interface to create parameter estimation problems in the PEtab format. What you see here is the interface the moment we opened the application. We have organized in two tabs. One, the data tables. This includes the measurements, the parameters we want to estimate, the conditions under which the measurements were taken, and the observables linking states of your SPML model to the actual measurement. And we got the tab of the SPML model where we have the antimony model and we have the SPML model. Antimony is a way to kind of human readable write SPML model, so you have both options. In the data tables, we can change the size of these things. We can make them visible or not visible. Some of them are currently not visible. We'll show them while we go through this tutorial. So what are we going to do today? We're going to create a very, very simple model, and we'll walk you through all the steps necessary, and we'll show you why it is really nice to have this application and how to work with it. If you are really unfamiliar and this is your first time, you can start the help mode here. It shows enter help mode. You just click on it, and now you can click on everything inside this the application and see what does it do. You can click on the whole table, but you can also click on the single columns, and it explains you what the columns are and what should go into the columns. You can just toggle off this helper mode by just clicking on it again. Okay, so let's get started. Usually we start with an SPML model. So let's get started. The reaction we're going to have a look at is the reaction conversion A to B. So we just want to model A gets converted to B. We are saying, okay, we're assuming mass action, so we say this is K conversion times A. So far so good. We also want to initialize our species as we're looking at the conversion. Let's say we start with A equal to 10 and B equal to 0. Okay, and our variables, well, we have already defined it. It's K conversion, and let's just say it's 0.3. Okay, so once you're done with writing all of this, you can just forward these changes to SPML, and you can see here now, well, we have a list of species, A and B, we have a list of parameters, we have K conversion, it's 0.3. Everything looks good. Data tables. The first thing we do is we import our data. Usually, let's do that. We can see here, we can just say file open. We have here this data table. Okay, so usually our data is organized in like a data matrix, and we have time observables and other observables. So in this case, we measure A and B throughout the time. The PEtab problem needs a single line for each measurement and each observable. So this would create for us 20 lines. We don't really want to do that. But thankfully we can just open it. If it's in this case, it asks us, okay, what is your condition? We say, well, this is condition 1. We don't really care about the condition, but just be aware that in here you fill out the condition you have done this under. You just give it a name. So we'll open it and we can see, well, it has uploaded all of this. It has given it the simulation condition, and it has added both the observable and the condition into the table. That's already amazing, but we can already see it's red. If we look at the information, it says, well, we have an empty cell. What is happening here? Well, we've not given it the observable formula, so we have not said what exactly are we measuring. And as we know, we are measuring A here and here we're measuring B. As you can see, the moment we fill in these things, they automatically check again, is this valid now? If it is valid, all good. We're going to remove the color. This one is still red because when it was created, these had problems. So it's even working interlinked. So we say check the whole problem. It checks the problem and says PEtab problem has no errors. Everything's good. Well, you might ask, why does it have no errors? We have no parameter added. Well, we have assigned a value to the parameter currently, so it just assumes this is a fixed parameter. But we want to say, well, we want to estimate this parameter. So what do? We enter the parameter and it's already suggested to us, well, it is k-conversion, so let's fill it out like this. And it fills out the nominal value that it takes from the model. That's nice. It says, well, we want to estimate it, and it gives it a log scale. Log scale is, you can choose between lin and log scale. We advise for log scale because it is just for parameter optimization, just a tad bit more efficient. It's still red. Why is it red? Well, we have not added bounds. Bounds is like the maximum and the minimum value we assume the model can take ever. And that is reasonable. So let's just put some values in here. We say, well, this is 0.001 and the upper bound is 100. And we can see everything turned green. So we now have a valid model. But let's have a look. How does this model look? For this, we can here go to view, and we see we have some things that are not visible yet. Let's add the data plot. As you can see here, we have added a data plot, and it takes all the data and adds them automatically. Let's resize this here a bit, because we don't need all the space. We might want to have some space for this. Okay. So, per default, the plotter separates the conditions or the observables. So we see condition 1, observable A. This is not as nice. We really want to see both of them together. So we can just click here and say group by condition. And so it takes this and says, well, now we have one plot. It's condition 1, observable A. This looks nice. We can also see that if we select this here, well, this is nice. Let's just say, let's remember this value and say, well, let's fill out 20.5. And you can see it automatically updates the plot. So it's an interactive plot. Let's revert this with just here, undo and reduce, and do it like this. We can also here delete columns through this. We can add rows, here delete columns, add columns, or you can also just right click and do those stuff here. Once we have set up the whole parameter estimation problem, we've added our data, we have filled out the conditions, we have filled out the parameter and the observable table. We've also checked the data, it looks reasonable. So now we want to have a feel, how does this model simulate? So in this case, we can just click here. There is an integrated simulator in the PEtabGUI. So you can just click simulate. This will take some time, as you can see. And then once it has done that, it automatically updates the plot. And as we can see here, well, this is not as good yet. It is a bit too fast. So if we change it, we can say, okay, let's just go with 0.1. Why not? And then we can just resimulate, and it does that perfectly. So we can see already we can have a first feel of certain parameters and the effects of certain parameters. This obviously does not replace parameter estimation problem. So we're basically done. So what we want to do now is we want to go ahead and save the problem. And it will start ask you what do you want to save it as. Let's just say simple conversion 2. We can save as a combined archive, a zip file, or a folder. We'll go ahead and save as a folder for now. Once we've saved it, we'll get a notification and we'll get possible next steps. This is meant for you to continue after you've created the parameter estimation problem. Part of this is you can either contribute your model to the benchmark collection if it is already a published article. You can obviously, this is the most important one, do your parameter estimation. In this case, we advise using PEpesto. You can go to the documentation, or you can go in our documentation of the PEtabGUI. You can have code examples, or you use Copasi for more advanced changes in your model. There's more tools supported here, including Amici, PEtab-GUI, and Data2Dynamics. If you want to check out all the tools that are possible, just check out in the documentation. If you already know where you want to go afterwards, you can, and don't need these tips, you can just say, don't show this after saving, close it, and never to be seen again. At this point, we are done with the parameter estimation problem creation. The next steps are up to you. I thank you for your attention, and I hope you've learned something.